Alright, here we go with a review of chapter number 1, the reservoir and the logging environment. Well, these are the topics that we will be covering. We'll start talking about the reservoir fundamental properties, which are lithology, porosity, fluid saturation, and permeability. Then the borehole influence, the filtrate invasion, and a few interesting topics. Remember, this will not be a whole reading. We're just gonna go skimming through it and making a pause on the more interesting or more relevant topics of it. You can go to the detail and read it by your own. I'm gonna give you my point of view on what I've been most exposed to as a field engineer. So the first question is why any company called a wireline logging company? Actually, is to get information to know whether or not they will be able to get hydrocarbons to surface. But in some instances, companies just require basic services like a triple combo. Sometimes they ask for a quad combo, and in many other occasions they require what is called special services like formation tester, magnetic resonance tools, etc. So, covering the fundamental formation properties, we encounter this lithology. What is that? This is basically the type of rock. And when we say type of rock, we're referring to the chemistry of that rock and also the physical property of it. Porosity. Porosity is basically the void spaces within a rock. In that space is where we're going to find hydrocarbons. Ugly. Regarding fluid saturations, well, this is basically what type of fluids you got down there, if it's water or hydrocarbons or some other thing. And permeability, once that you know that you got hydrocarbons down there, you're really interested in knowing about whether or not you're going to be able to extract it. So permeability refers to the property that of the rocks that relates the interconnected pore spaces. So it's basically whether or not you're going to be able to produce that rock. We're going to be covering that. But yes, definitely you're going to be exposed to these 4 key parameters: lithology, porosity, fluid saturations, and permeability. Well, here we talk a little bit about lithology, and please bear in mind that you're going to be exposed to the main 3 types of lithologies: sandstone, limestone, and dolomite. There are many other, but you should keep an eye on these 3. When we say sandstone, here you have on the screen, this is the chemical composition. When we talk about limestone, you got it here, and dolomites are made of this. Then we talk about the framework, which are easier to produce. And this final comment is about why knowing lithology. It serves for subtle purposes. You can rate it on your own. But that's basically the type of rock. Now let's go with porosity. Porosity is denoted with the Greek letter phi. Yes, you're going to see that letter a lot. And the first things I would like to add to this is that there are 2 types of porosities: absolute porosity and effective porosity. Remember that we said that porosity was that void space within the rock that contains hydrocarbons. Well, what we really want is that those pore spaces to be interconnected so fluids can move through it and go to surface. But that is not always the case. Sometimes that pore space is isolated and there's oil in there, but you can't get it. So we want to differentiate between those pore spaces which are interconnected and those that are isolated. It doesn't mean that if they're isolated you can get it, but you will have to do some extra work on it, like fracturing, etc. And this is a better example, a better way to understand it. Imagine, check this out, figure 1. Examples of primary porosity in sedimentary rocks. Pore space is shown in blue. So imagine for a moment the hydrocarbon or oil is the blue thing. So here you have blue oil and then a piece of rock, and oil and then a piece of rock. You want all this space to be interconnected so that oil can move to the surface. What happens if hydrocarbons are inside of the rock and they're not connected to anything else? Well, you will have to frack. And this is in these images, there is a differentiation between primary porosity and secondary porosity. This is just basically the way porosity was created. And here we have a difference on that. Well, before finishing with porosity, a key comment on this. In standard services like triple combo, you get total porosity from the combination of the neutron log and the density log. Those two tools will give you an indication of total porosity, and they are into the triple combo. Why adding a quad combo? Because the 4 sensor that is added in a quad combo is also a tool that indicates porosity, but in this case the sonic tools will give you an idea of the effective porosity. So that is a distinction I want to make clear. Whenever you're talking about porosity, remember that void space, and always bear in mind that you have to consider whether we're talking about absolute porosity or effective porosity. Now, fluid saturations. Well, as I told you before, this is about whether we have water or oil or any other fluid in that pore space. With this image, you can see it. There's a matrix of rock and a percentage of hydrocarbon and a percentage of water. A really interesting point on this is that usually when you run a triple combo, you use the values from the resistivity or the induction tools to calculate water saturation. And the way we determine if we have hydrocarbons is that we assume that everything that is not water is oil. Yeah. So we will see in later chapters the Archie equation, but at the end of the day, when you make calculations for water saturation, then the formula for hydrocarbon saturation is 1 minus water saturation. So that is an interesting thing. Let's move on. Okay, permeability. So permeability, in short, I like this one, refers to rock ability to transmit the fluid it contains. Then it is expressed in Darcy, and this is the technical definition, you can read it. Is a Darcy, which is the permeability of a porous rock that will allow the flow rate of 1 millimeter per second of a fluid of 1 centipoise viscosity through a 1 square centimeter cross-sectional area under a pressure gradient at 1 atmosphere per centimeter. Wow, that's a technical way of saying that is the ability, it's a rock's ability to transmit the fluid it contains. But yes, you will hear about Darcy. A comment regarding permeability, you will also see that there are two types. There's absolute permeability, which is noted with Ka, and effective. We should see it somewhere here. Effective permeability. There is a distinction, basically because when you talk about absolute, you're considering only a single fluid in that rock, and when you're talking about effective permeability, you're considering more than one phase and more than one type of fluid, which is almost the case. A more realistic scenario. So there are another qualitative indicators of permeability. For instance, in resistivity logs, they offer different resistivity curves. So if you're logging through a non-permeable area, the three curves are going to read the same. But we'll see that later on. Regarding the borehole influence, the filtrate invasion, I would like to go straight to this graph. You should definitely get familiar with this graph. Once you drill a hole, you consider three zones: the flushed zone, the transition zone, and the unindated zone. What is that? On this area, the flushed zone, drilling fluids, if the formation is permeable, then you're going to enter on this area and you're going to be mixed with the original formation fluid. The transition zone, it has both as well. And the unindated zone is like the most representative area, the virgin area. Usually we'll tell you the properties of this formation, but knowing and comparing how is the behavior of your sensors in these three areas will give you more information. But for now, just bear in mind that whenever you're talking about these letters, you should know it. Okay, what makes a reservoir? That is a good question. A reservoir is defined as any subsurface formation with enough porosity to store fluids and enough permeability to transmit them. At the end of the day, you just want to produce hydrocarbons. Then there is a distinction here about siliciclastic and carbonate. There is an overview of where can you see or find siliciclastic reservoirs, where can you find carbonates. Just keep in mind about the chemical composition of this. This is an interesting behavior. Porosity decreases with depth in both siliciclastic and carbonate reservoirs. So when you're logging, this should be a general trend. Porosity should decrease. These are good to have an idea of the order of magnitude. This is to have a number in mind. High porosity, more than 20%, and high permeability, more than 100 millidarcies. So you start to get exposed with how much is high porosity or how much is high permeability. The original porosity, that is not necessary. You can read about your own. A few images of sand, grains. This is just about how that porosity was created, or whether it was primary or not. Control permeability, rock properties, borehole invasion, the reservoir, and you. Well, that was pretty much everything. Thanks for watching.